Okay, here is the slides I shared with you in Avenue to Learn. And in the lecture today, we will continue the review about the pavement design. Actually, last week we introduced the fundamental features of the flexible pavements, and we said that there will be some other type of the pavements. So in this week, we will continue this introduction, including the basic definitions of those type of the pavements and some of the unique features. Different from the flexible pavement, the rigid pavement is another commonly applied structure for the freeways and local roads. We define this type of the pavement as the rigid pavement because it contains a very stiff top of the surface, and the surface is usually made with the concrete slab. So we will actually in US and in Canada, the Portland cement concrete slab are commonly applied, and this figure shows the structure of the rigid pavement. Usually has 3 layers. The subgrade layer, which would be the nature soil. On top of it, that will be the granular subbase layer. And at the very top, we will have the concrete slab layer. Usually, the thickness of the concrete layer is around 150 millimeters to 300 millimeters. And for the base layer, it varies between 100 and 300 millimeters. This structure is actually different from the flexible pavement if we go to compare these two different pavements. For the flexible pavement, of course, we have the subgrade, which would be the base of the pavement. And it has more layers. From top to bottom, we will have the asphalt concrete surface and the binder layers. All those are defined as the asphalt concrete layer. And we have the granular base layer and subbase layers. And depending on the loadings from the road traffic, the thickness of the pavement will also be different. So the most critical difference between the rigid and flexible pavements is actually the materials they select for the surface layer. For the rigid pavement, we will use the PCC slabs. For the flexible pavement, we will use the asphalt concrete. If we go to check the features of the rigid pavement, we can see that rigid pavement will be the pavement with a very hard surface, and I can have the sufficient beam strength, which is supported by the PCC slab, and is able to bridge over the localized subgrade failure and areas of the inadequate support. So this means that for the rigid pavement, most of the load and all the stress is supported by the PCC slab instead of the layers behind. So we have to make sure that the surface is hard enough. Also, for the distribution or the load transfer behind the surface, usually we consider the beam action, and this will help us to generate, actually help us to prevent the generation of very high stress at the bottom of the pavement structure for the rigid pavement. And with the if we go to see the distributions of the rigid pavement, we can see that the stress would be, the distribution of the stress would be flat compared, and this one is different from the flexible pavement, which is more concentrated and it will have a very large value. You don't need to worry about the details here, as we will introduce how we're going to analyze the stress and how we're going to design the rigid pavement in the future lectures. And the materials presented here is just an overview about what the pavements, what different types of the pavement looks like in the design. And also there are some unique features for the rigid pavement. Usually the deflections, which is also represent the deformation from different loads. The deflection from the rigid pavement is very small, And that's also the reason for us to define the pavement as rigid. And also the pavement has a very high flexure strength. With that, the stress will not be transferred to the bottom of the pavement structure. So we don't need to worry about actually the rows of the sublayers or the such as the subbase layer or the subgrade. It's not necessary to be very strong. It's different from the flexible pavement. In the flexible pavement, we have to seriously consider using the bottom layers to support the surface layer. And another thing we have to consider is about the PCC slabs. Usually for the flexible pavement, the surface is continuous. But for the rigid pavement, as we have to use some slabs. And it's usually for the slabs, we have limited dimensions. So we need to consider the multiple PCC slabs for the construction of the pavement. And also, it's possible for us to develop a rigid pavement with continuous slabs. That will be some of the continuous Portland cement materials during the construction. But with this kind of design, we need to think about the reinforcement to make sure that the slab can support for very heavy load during a long time. And we need to think about the transformation of the load from one location to the next one. In addition, the rigid pavement will have a very high cost for the construction, especially for the initial investment, as the cost of the PCC, the Portland cement, is actually very expensive. But as the pavement is the stiffness of the pavement is very high, and it can last for longer time. So in that sense, the maintenance cost could be low. And we also know that as the surface is very high for the rigid pavement, so there will be very small deformation from the surface, and then with that kind of prevention of the for the transformation of the distress, the lower layers will have less deformation. And for the design of the slab, the PCC slab, we need to consider the slab actions, which means that how the slab will react to different types of load at different locations. And in general, we want this slab have very high flexure strength. And in addition, as we consider the PCC slabs, if they are not continuous, then it's hard for us to identify the grain-to-grain load transfer from one slab to another one. And usually we need to think about some of the connectors to generate the to transfer the load from one slab to another one to ensure that they can distribute the load evenly and prevent some of the crackings at the corner or at the edges of the slab. And for the rigid pavement, there's another issue which will be related to the maintenance. Even though we say that we don't need to maintain the rigid pavement frequently, but if there's any issue or if the pavement experiences any failure, then repairing the rigid pavement will be very expensive, because we need the materials will be very expensive, and also very difficult for us to remove the materials from the road. And regarding to the lifespan of the rigid pavement, usually for the rigid pavement, it can last for a longer time compared to the flexible pavement. And overall, considering the low maintenance frequency, then we can conclude that the overall maintenance cost for the rigid pavement will be low compared with the flexible pavement. But for the initial construction cost, rigid pavement would be much higher. This figure actually shows the one example about the rigid pavement, and this is some typical rigid pavement. It will consist of multiple PCC slabs. You can see those kind of rectangles which will be laid on top of the surface. And for those pieces of the slabs, they are actually connected by the dowel bars or the tie bars. And this one, the tie bars is usually connecting the slabs laterally, and the dowel bars will connect the slabs longitudinally. These two bars will be applied to transfer the shear force between different slabs, and they are able to share the load when the vehicle is moving from one slab to another one. And of course, you can see that the for the rigid pavement, the materials is a Portland cement concrete, and the surface regarding to the surface, we need to think about applying some of the textures on the top to make sure that it can resist it can have some skid resist, or on the other way, you will try to make sure that the surface of the road is smooth enough and reduce the noise caused when the vehicle is driving on the road. And for the design of the rigid pavement, what we need to think about is actually we only need to most of our effort will be spent on calculating the thickness of the PCC slabs to make sure that it can support the designed traffic load and try to sustain for different weather and the temperature conditions. For the actually in reality there will be a lot of types of the rigid pavement. The most common one is called the joint plan concrete pavement, and you can see that this type of in this type of design we will have the limited dimension of the PCC slabs, and they are all connected by the dowel bars or the tie bars to transfer load between the slabs. But for this kind of design, does not have any reinforcement inside each PCC slab. In that sense, this will actually cause some of the issue about the distress in the middle of the PCC slab. So in order to solve that issue, we will have the design, which is called the joint reinforced concrete pavement. And in this design, we will apply some reinforcement with the steel bars, which will be placed inside of the PCC slab, so that it can have the better support about the load inside the PCC slab. With this kind of reinforcement, the size of the PCC slab could be longer. Like for usually, if we only consider the plan design, the width of the PCC slab is around 3.5 to 6 meters. But for the joint reinforcement design, it will be as long as 7.5 to 9 meters. There's another type of design which is called the continuous reinforced concrete pavement. In this kind of design, we don't have the slab. Actually, the entire pavement will be considered as one slab, and it will have the continuous reinforcement applied for the entire road. And of course, this kind of design does not need any joint because it's the one integrated system and does not have any connections between the slabs. And this one will be more sustainable compared with the previous two design, but it's rarely applied. This design is applied in US and Europe, but it's rarely applied in Canada. The last one is called the pre-stressed concrete pavement. I did not find a good figure to represent this design. You can, if you're interested, you can try to search online. Basically, for this type of the design, you can we will apply the some stress before we place the PCC slab in the field. With that, it's able to provide a larger support for the traffic load. And this one it's applied at some locations in Canada, but it's not quite common. And another issue, especially when we consider design of the rigid pavement, is about the load transfer from the top of the surface to the bottom of the pavement structure. Actually, the load transfer under the rigid pavement and the flexible pavement are very different. For example, if we consider these two figures, two examples. On the left, that's in the rigid pavement design. On the right, that's in the flexible pavement design. If we apply the same load to the pavement structure, say around 30 kilonewton. For the rigid pavement, as the PCC slab is very hard, and you can consider, if we consider the slab action, you can see that the load will be almost evenly distributed behind the PCC slab. In that sense, you will observe a very flat distribution of the stress. While for the flexible pavement, we do not have this slab action. Instead, the load will be distributed with a more concentrated figure, more concentrated graph. The load actually be directly behind the distress directly behind the tire will be very high, and then it will drop sharply around the center of the loading area. So usually for the if we apply the 30 kilonewton load to the PCC slab, the pressure behind the slab is less than 0.2 megapascal, while for the flexible pavement, the maximum pressure behind the surface layer, the asphalt concrete surface layer, could be as high as 2 megapascal, which is around 10 times higher. This also indicates that we need to have a stronger support for the pavement structure, actually for the flexible pavement structure, while for the rigid pavement, the thickness behind, as well as thickness for the subbase layer, should be can be smaller. And so that's the difference between the rigid pavement and the flexible pavement. Another issue is about the load transfer at the joints. This is about the load transfer at the longitudinal direction. Actually, it's not from the vertical direction. So here we know that if we don't apply any joint between the slabs, you will observe that the load, if you drive your car from one slab to another one, then the load will always maintain at one slab. And actually the other slab will not help you to distribute the load. So that's the case without the joints, and 0% of load will be transferred from one to another one. But if we apply a dowel bar to connect two PCC slabs, then this kind of bar can actually transfer the load 100% from one slab to another one. And actually there's another kind of design which is applying the subbase behind the PCC slab. With the subbase behind, we can actually partially transfer the load from one slab to another one. And this kind of transformation is actually caused by the shear force between the aggregates from the subbase under the joint of the two PCC slabs. For our analysis about for the design of the rigid pavement, if we don't have any dowel bars, then we need to think about what's the percentage that we have to consider from the subbase to identify the thickness of the PCC slab. So this table actually summarizes the difference between the flexible pavement and the rigid pavement. For the flexible pavement, we are using the asphalt concrete as the surface layer, while for the rigid pavement, we apply the Portland cement concrete. For both of them, we can consider they are using the layer system. For the flexible pavement, we have the asphalt concrete layer, the base layer, and subbase layer. For the rigid pavement, actually conventionally we don't have any base layer. We only have some of the subbase layer, and then on top of it there will be the PCC surface layer. And for the load transfer, we have the normal stress distribution to the shear stress through all the layers. So the load is transferred gradually from surface to the bottom. While for the rigid pavement, we only need to think about the slab action, and usually the stress at the bottom of the PCC slab would be very low, while for the flexible pavement, the stress level would be very high. Depending on the different layered system and the different stress distributions, we will observe different type of the distress is applied for the flexible and rigid pavement. For the flexible pavement, what are we gonna observe about the distress is rotting, and which is usually along the wear path, the fatigue cracking, the top-down cracking, and actually in our tutorial session, the first tutorial session this week, we'll have some introduction about different type of the distresses applied for flexible and rigid pavement. For the rigid pavement, the common type of the distresses will be the mud pumping, the fatigue cracking, and so on. The design of the flexible and rigid pavement should have some consideration about minimizing the all different type of the distresses under different seasons and weathers with different load. So that's the rigid pavement design, and the next one, which is less common for the heavy traffic, is the interlocking concrete pavement unit. And this one is usually applied for the parking lot, the driveway, or some areas with very small or very low traffic volumes. This kind of design, the figure on the right actually shows the interlocking concrete pavement. And usually it contains on subgrade layer, which would be the nature soil, and an aggregate base layer, and then has a sand bedding layer. And on top of that, we will have the concrete paver bearing surface, which will be some of the blocks. And it will also have the edge restraints, which will try to control or try to set at the edges of the road or the driveways, and the drainage structures to remove the waters as far as possible. As for the interlocking system, the surface cannot resist any waters. All the waters are actually the entire pavement is permeable, and all the water should be removed at the bottom of the pavement structure. And you will also may notice that for this kind of design, the road might be very slip when, especially after the rain. So we need to think about how to drive the cars on the roads slowly, or even walking there carefully. And as the road is built with some of the cracks, so you can see there will be some crackings at all the locations of the pavement. And this also indicates that we cannot further create any new cracks. And as we mentioned that this kind of pavement is only applied for the parking lot and some of the areas with very low speed. And this one is easy to work on a small area with certain issues, like if you want to quickly just remove a portion of the pavement and replace it with a new one, then we can apply the interlocking concrete pavement. And for the analysis about the performance of the interlocking concrete pavement, we can actually apply the analysis from the flexible pavement. These two types of the pavement will have very similar features. And this figure shows the structure of the interlocking concrete pavement. So from the top, from the bottom to the top, we have the subgrade soil, and it covers with the compacted aggregate subbase layer, and then with the compacted aggregate base layer, and apply some bedding sand. As I say that the bedding sand is mostly applied for the drainage purpose. And then we will have some concrete pavers, and in between all those pavers, you will have we will apply some of the sand to build the to increase the shear force between different pavers. And the one thing we have to consider is about the edge restraint. Also would be the curb. As for all those for the interlocking concrete pavements, for most of the for the main roads, they are not bounded. So in order for us to prevent the movement of the concrete pavers, we need to have something at the edges of the road to prevent the so that the pavers will not be moved out of the pavement structure, and we can maintain the surface of the road smooth, as well as to keep the structure consistent for a certain period. And so that's the basic three major types of the pavement structures, and also, as I mentioned, there will be some of the unpaved roads, but it does not involve with any design about the pavement, so I will not introduce them in this lecture. So this would be the introduction of the pavement types. Do you have any questions so far? If no, then I will continue the lecture. So regarding to the pavement design, actually for this class, we will only focus on the flexible pavement design and rigid pavement design. For both of them, there are some common factors we have to consider. As a designer, at the beginning, we need to think about multiple methods to complete the design. So we have to list the different design plans. So once you work with one plan, you always have some backup plan. And then we need to summarize the design factors, such as the materials, the traffic loads, and also we have to recognize the variations of those factors. For example, for the material properties, the properties actually varies at a different time of the year. So this kind of variation should be considered in the design. And the materials is one of the important factor. Is not only related to the performance of the pavement, but also it will control the budget of the entire pavement project. So generally, we want to maximize the use of the local materials, which will be very cheap for you to develop the pavement structure. And as I just mentioned, the impact of the environment to the pavement structure should be carefully analyzed, including the different seasonal impact to the material properties, the weather conditions, the moisture levels and temperatures, And the design lives and the reliability of the pavement structure over the design life should also be considered. We want to make sure that pavement structure can last as long as possible. And finally, the cost or the budget of the project is a key limitation for you to conduct the pavement design. And another issue we have to consider is the purpose of the pavement design. Usually, for the road traffic, for the pavement of the freeways and the local roads, they are not designed for the passenger cars because the load from the passenger cars is relatively small. Usually, we have to consider the pavement for the truck volumes. The tire pressures of the truck is much higher than the passenger cars, and they will be the most important factor for us to observe the distress or the failures of the pavement structure. So in the design, we need to estimate the traffic volume, and indeed we have to convert everything to the truck volumes. This would be the variables as I listed previously. We have to consider the materials, the traffic load, the environment, the performance and distress, construction cost, rehabilitation cost, and also the life cycle cost. For the traffic, we need to think about the volumes of, especially the truck volumes. If we consider the road with multiple lanes, we have to identify the distributions or the percentage of the trucks which will be traveling on each lane, and we have to design with the lane with the highest percentage of the truck. And we also need to analyze the load of the vehicles and convert the load of the vehicles and estimate the distributions of the loads at different layers of the pavement structure. For the environmental factors, we have to consider the precipitation that will be related to the moisture, and the temperatures and also the gradients. The temperature will affect the property of the material or the soils, and the gradients will be related to the drainage of the pavement, the freeze soil effect, the wet and dry cycles of the local area. Those are all affect the material properties. And of course, as I just discussed, the material property is the key factor we have to consider. We need to carefully analyze the material property for each layer, especially for the flexible pavements. They have to support the designed load or designed stress applied to each layer at a different depths in the pavement structure. And for the pavement structure itself, we have to think about what kind of system we're going to need to use, whether we're going to use the layered system or we just use the rigid pavement with a smaller number of the layers. And the maintenance schedule, how often we have to maintain the pavement structure, and what's the cost of the maintenance at every time. Regarding to the design methods, there will be 4 different types of the methods. The first one is called the experience-based method. This one is very intuitive. We just apply the past successful examples, the pavement examples, and we will build the similar pavement structure for the road in the similar conditions. And this is not reliable, especially it's not sustainable for the future development of the cities. The traffic condition could be changed, and the weather condition could also be different, and so on. More advanced system is called the empirical method, and in this method we will collect the data, the pavement, the design of different pavement structures, the distress information, and the the changes about the pavement layers over the time. All this information will be collected, and we also do some tests about the material properties. And then using this data, we will build a statistical model of which will just directly show you the relationship between the thickness of each layer with respect to the traffic load, the material properties, and also the environmental conditions. This method, the empirical method, has some it's more reliable, but without knowing the insights about the design, we cannot guarantee that we will always have a reliable design at all different situations. The next level design is called the mechanistic and empirical method, which will apply the empirical models with the mechanistic analysis. So in this method, which we call the ME method, we will do the calculation about the pavement stress strain deformation with the material properties and also the loading conditions. And then we're going to use the empirical models with the calculation results to estimate the thickness of the each layers for the pavement structure. This one is actually the most common method applied for the design in US and Canada. The last one, actually in this class, we will focus on the ME methods. The last one is called the mechanistic method. In this method, we will do the theoretical analysis about the pavement stress strain deformation. And also we want to calculate the thickness of each layer based on the some mathematical models from the material features. And this one should be the most reliable model, but the calculation would be very complicated, and it's hard for us to extend this one to different areas, because in reality there will be a lot of variations about the materials and the environmental conditions. So the based on different physical consideration or different factors, most of the engineers were still using the ME method in nowadays. So that's the factors we have to consider for the pavement design. And the last things like the design, the pavement design is not applied for the highways. Is also one important issue for the airport design. But for the highways and airports, there are some clear difference. First of all, the geometries of the highways and airports will be very different. The usually for the highways it will be very long, but for the width of the road that will be very small. But for the airport, it has to support the airplanes, so the width of the road is very large, and it's only located in a small area. Of course, for highways, it's only applied to support the road traffic, the trucks and passenger cars. But for the airports, it has some support for the service vehicles in the airport. But the major purpose of the pavement in airport is for the airplanes, the taking off and landing. So the pressure, the distress or the load to the pavement will be very different. For the types of the distress, the highway and airport pavement will be similar, but usually for the airport it has much higher requirements. And regarding to the design, we can apply the flexible pavement or the rigid pavement; those will be the same, but the calculation of the thickness will be different. So this table compares the difference between the highway and airport pavement design. Usually for the highway pavement, as we consider the distributions of the tires, the distress will usually applied at the edges of the pavement, which will be the location close to the lane markers. and along the rail path. While for the airplane, and usually there will be 3 pairs of the tire, and one is actually located in the center. So considering the distributions of this the load to these 3 pair of the tires, the distress is usually aligned in the center of the pavement structure. And the load is the most critical difference between the highway pavement and the airport pavement. For the highway pavement, we will consider the traffic load, and usually that's around 40 kilonewton for the dual tire system. But for the airport, they could be as high as 180 kilonewtons. And with regarding to the traffic volumes on the highways, you will observe like the traffic varies a lot depending on how busy the road it is. The traffic can vary from 100 to 2,000 trucks per day, while for the airport, the volume would be much smaller. For the entire design life, it's only around 20,000 to 40,000. And for the highway, the traffic is usually estimated based on some of the sensors installed on the highway or some of the surveying data. But for the airport, we know exactly when the airplane will depart or land from the airport, and how many of airplane were running in the airport. So we have a very precise number of the traffic, and we will have a better control about traffic in the airports. Considering the last thing is about the tire pressure, considering the traffic load and the size of the tires and distribution of the tires. For the highway, the tire pressure is around 500 to 900 kilopascal, while for the airport, it's much higher. It's more than 2,700 kilopascal. So those are the major difference between the highway and airport traffic, and that's the factors we have to consider when we're designing the pavement structures for freeway and airports. And one last thing that I want to introduce to you is about the design life, or we should say that the design period. Actually, all the pavements are designed to fail after a certain period of time. So we cannot guarantee that the pavement can last for like 100 years or more than 100 years. Usually only last for 20 to 50 years. And in the design, we want to make sure that the pavement is safe and smooth, and it's comfortable for everyone to use during the design life. But if your pavement is not designed properly, you may experience functional failure and structural failure. So there are some difference between the functional and the structural failure. Usually structural failure indicates that there's some breakdown about the pavement structures, like the one layer is a breakdown, and or there's a very high, very large cracking on the road, make it impossible for the pavement to support the traffic on the road. While for the functional failure, it's more related to the experience of the road users on the road. For example, if there are a lot of cracks, small cracks, alligator cracks on the road, the drivers will feel that it's not as smooth, and it's very disturbed on the road. So this indicates that you need to consider to either rebuild the pavement structure or do some maintenance about the pavement surface to make sure that the road is smooth enough. And at the most of the time, these two types of the failures could be considered by very heavy loads of the traffic, or the inadequate design of the pavement structures, and then the traffic or the weather conditions will increase or make the situation of the pavement conditions very worse. So that's the overview about the pavement design, and start from next week we will have an introduction about the material or the soil properties, and that will be the preparation for the pavement design for the flexible and rigid structures. Okay, I think that's all about the lecture today. And do you have any questions so far? You can raise your hand if you have any questions. I saw one question is regarding to the tutorial session. For the tutorial session, if you choose in person, you can still take the online tutorial session, which means that you can access to the tutorial through Teams, and we will create a meeting under the tutorial channel. But for the lab sessions, if you choose in person, you must be there to conduct lab with your with your teammates. For the tutorial session, we will offering both in-person and tutorial session, in-person and online sessions, and they were actually synchronized. So you are actually taking the same session. For the first tutorial session, which will be offered this Wednesday, we will learn the definitions about different distresses applied for the flexible and rigid pavements. Okay, do you have any other questions? Okay, if we don't have any question, then that will be all today, and I will turn off recording the video. And remember that if you haven't